What is up, guys? It's TimeForDillon back at it again with another crypto video. What is up, guys? TimeForDillon back at it again with another electronics tutorial. In today's video, we're just continuing on with our Elegoo R3 Uno project kit, and we're going to be doing lesson number 4, which is all about the RGB LED. So without further ado, let's jump into today's lesson, get started with this awesome project. So this lesson that we're going to be doing just builds off of all the lessons we've been learning so far. We're just going to take it one step further. So let's jump into this. First thing we got to do, as you can see, is we got to pull out our components. So we need our R3, we need the breadboard, the 830 tie points breadboard. That is literally the breadboard we used in the last lesson. We need 4 male-to-male wires, the RGB LED, which if you scroll down, it's this one, so the clear one with four leads, it looks like. And then, of course, we need 3 220 ohm resistors. So let's go ahead and jump into our box and pull out those components. So we're going to need our R3, bingo bango, R3, set that there. You're going to need our breadboard, bingo bango, same one we used in the last lesson. We're going to need our resistors, so we need 220, and we found out in the last lesson that they are in fact labeled, which helps a lot. So I'm just going to use that same resistor that I used in the last lesson. And then 2 other. Boom. I've seen some people, they just throw these away after they use them once. I don't know. I'm cheap. I'm going to just keep them. I'll just stick them back in here. So 3 of those. We need 4 male-to-male wires. So in the last lesson, I used the same color wire, but I think it might be just a little bit better to maybe use some different colored wires just to make our life a little easier.
So let's go ahead and get these out. We'll do one R. We'll do one G. Let's do green. We'll do a blue. That's kind of long. Let's do a sharp blue. And then we'll do a black. And there's a black. Boom. Zip tie these back up.
It's located in this box. It looks like we have 2 of them. And make sure you get the one that has the 4 legs or the 4 terminals, whatever you want to call it. It's this one right here. You can see that's 4 of them. Well, and that's it. So we don't need this box anymore, so let's close it, put it to the side, and get started with this lesson. Oh. So jumping back over, let's take a look. So component introduction, RGB. At first glance, RGB, red, green, blue, LEDs look just like the regular ones. However, inside the usual LED package, there are actually 3 LEDs, 1 red, 1 green, and 1 blue. By controlling the brightness of each of the individual LEDs, you can mix pretty much any color you want. We mix colors the same way we would mix paint on a palette. Or if you guys have ever used Photoshop or anything like that, you guys know RGB, 3 numbers that will control the color. If you've done any type of coding, website design, you got to use RGB to make the color of, the website. Unless you use one of the hard-coded ones, but most people just use RGB. Okay, the hard way to do this would be to use different value resistors or variable resistors as we did in lesson 2. But that's a lot of work. Fortunately for us, Uno R3 board has an analog write function that you can use with pins marked with the tilde key to open the variable amount of power to the appropriate. That's pretty cool. Instead of using resistors, we can have our very own board, which has, if you guys take a look at that, some of these terminals have little tilde marks. See, 11, 10, 6, 9. Yeah, so a bunch of these things have tilde marks, so those are the ones that can variably control the amount of voltage that gets sent to this component. Pretty cool. The RGB LED has 4 leads. There is 1 lead going to the positive connection of each of the single LEDs within the package, and a single lead that connects to all 3 negative sides of the LED. So I'm guessing that's the cathode. So the cathode is probably the negative, and then which is it looks like the longest one. If you can see, it looks like the cathode. The one to the left, the single one right here, it's not focusing. You can see it. This one right here looks like it's the red, and then these two over here look like it's green and then blue. Pretty cool. This is what the diagram looks like. So here's a photograph. You can see 4 electrode LEDs. Every separate pin of green or blue or red color is called the anode. You will see the plus sign next to that. Cathode to the ground. If you connect it other way around, the LED will not light. The common negative connection of the LED package is the second pin from the flat side. It's also the longest. So the negative is the longest. Cool. And will be connected to the ground. So we connect the longest one to the ground. Each LED inside of the package requires its own 220 ohm resistor to prevent too much current flowing through it. The 3 positive leads of the LED, 1 red, 1 green, and 1 blue, are connected to the Uno using the pins. Cool. So color. The reason you can mix any color you like by varying the quantities of red, green, and blue light is that your eye has 3 types of light receptors. Wow, I didn't know that. Pretty cool. Red, green, and blue. Your eye and brain process the amount of red, green, and blue to convert blah, blah, blah. Okay. In a way, by using the 3 LEDs, we are playing a trick on the eye. The same idea is used in TV. Yeah, with the pixels. It's like a combination of pixels. With the LCD has red, green, blue color dot next to each other, making up each pixel. Very cool. So if we set the brightness of all 3 LEDs to the same, then the overall color of the light will be white. If we turn off the blue LED, we'll just have red and green, and the light will appear as yellow. Oh, I like this diagram. So we can get purple from red and blue, cyan from green and blue, white from all of them, none of them, it's off. So we can control the brightness of each red, green, and blue parts separately, making it possible to mix any color we like. Black is not so much a color as it is the absence of light. Therefore, the closest we can have, black is if we just turn them all off. Got it. So theory, PWM, pulse width modulation. And I'm pretty sure this is what this thing is over here. When you plug this guy in, which you'll see right now, I'm pretty sure that's what this is, the baud rate. I think that's the exact same thing. But we'll unplug this for now. We're not ready to start with the lesson. All right. So PWM is a technique for controlling power. We also use it here to control the brightness of each of the LEDs. The diagram below shows the signal from one of the PWM pins to the Uno. So 0 to 5 volt, about 50%, 90%, okay. So roughly every 1/500th of a second, the PWM output will produce a pulse. The length of the pulse is controlled by the analog write function. So analog write 0 will not produce any pulse at all. And analog write 255 will produce a pulse that lasts all the way until the next pulse is due. So that means it's always on. So there's 256 values, base 2, like everything in computers. But you start with 0, just like programming. So the index starts with 0, goes up to 255, which makes 256 values. Okay, if the output pulse is only high for 5% of the time, then whatever we are driving will only receive 5% of full power. If, however, the output is at 5 volts for 90% of the time, then the load will get 90% of the power delivered to it. We cannot see the LEDs turning on and off at that speed, so to us, it just looks like the brightness is changing. Cool. Dude, that's pretty cool. So this is what the schematic looks like. Well, actually, all of this right here is where the board's going to be. And then we're going to have some jumper cables to connect here, along with 1 jumper cable to connect to the ground. Awesome. Cool. And this is a closer look. So my guess is you could pretty much put this thing anywhere on our board, as long as we have the ground connected to the ground, which is connected to the ground. The red side, which if we scroll up, is the one next to the cathode. Next to the longest one is the red one. So the red one connected to the 220 ohm resistor, connected to the red jumper cable, which will then go to the 6. The green, which is the one next to the cathode, right? I think they're remaining consistent with the colors. Yeah, so they are remaining consistent. That makes it nice. So the green positive node, or the positive terminal on the RGB LED, is connected to the 220 ohm resistor, which is connected to the jumper wire, which goes to the 5. And then we have the blue, which is connected to the 220 ohm resistor, connected to the jumper cable, which is connected to the 3. So we're going 6, 5, 3, ground. Okay, perfect. And then we'll jump into the code. So first things first, let's go ahead and connect our thing. I am just going to make it very easy for us. What I'm going to do is I'm going to connect everything exactly how it's connected here. So remember that the long side, right, the long one, if you can see the long one, that's the cathode. That one needs to be connected to the ground. So what I'm going to do, it looks like he has this on 50. I don't think it really matters, but we'll just try and remain consistent. So boom, we'll have this here. We got to separate this a little bit. So you separate it a little bit, maybe a little more, like that. And then we're just going to shove it into each one of these holes. Make sure you remember where the long one is, okay? You got to make sure that the long one gets connected to the ground, which means that there's no resistor for that one. So what I'm going to do is I'm just going to grab the black cable, which is going to be the ground, and stick it where the cathode is, right next to it. So it looks like that. Boom. And like I said, I don't think it really matters where on this board you put it, as long as you have it on this side of the disconnection in the middle, so that we can connect the resistors from this side to this side. Cool, so that's what we're going to do now. We just need the 220 ohm resistors, which we pulled out, and we're just going to hop it over to the next side. Starting with this one. We'll go to the next one. And while you guys are waiting for me to do this, I'd like to tell you about today's sponsor, me. I don't have a sponsor. My sponsor is my paycheck. So if you guys like this, just drop a like, leave a comment, let me know what you want me to build once we're done with this lesson, because that's really why I'm doing this lesson, is so that I can get some skills, so that I can build some pretty cool things. Because we know how to program now, and we're learning electronics. Pretty soon we're going to be building some pretty cool systems. I can't wait. This one's not wanting to comply. There we go. Get in there, sucker. Oh, okay, last one. And the cool thing about the resistors, like we learned in the last lesson, is they can go either way. So it's not dependent. The direction is not dependent. So make sure it's in there nicely. Boom. Cool, so everything's in there now. So now we just need our RGB. Well, and remember, just go off this diagram right here. Boom. Red, green, blue. Because we did validate that it is the same on the cathode. Red, green, blue. Alright, so the red one we are going to stick right here. Make sure you guys are connecting these in the same line, because if you don't, something's going to pop. So red goes there, green goes here, and then blue goes here. And make sure you guys skip. See how I skipped that one series of lines? That's because that's where the black cable is going. Boop. Right down this one. So you want to make sure you don't plug anything in to that one, because that's where the ground is. Okay, cool. So now we're going to connect it to our R3. And like I said, so the black one goes to ground. So if you look here, we have a couple grounds that we can go to. this one is the one I'm going to go to, even though there's some on this side down here. There's some grounds over here. The two right there. If you can see. Don't go to those. They're all the way across the board. Don't go to these. Go to this one up here. So the black one goes to the ground. The red one goes to the 6. If you can see, the 6, the red one goes to. I don't know if you guys can see that. The 6, the green one goes to the 5, so right next to the 6. And then the 3. And just to make sure, just remember it goes to the one with the little squiggly mark on the top, the tilde. I think that's what it's called. Bingo, bango. And there we go. We are now wired up. We're connected. We're looking good. And we are ready to plug this sucker in. So let's go ahead and plug it in. Boom. Bingo, bango. And jump back over to our PDF so we can see what the code is that we need. So after wiring, please open the sketch and folder path, tutorial, English code, blah, blah, blah. So where this is going to be located is wherever you downloaded the PDF, right? Because you either got the CD that's in here. You got the CD that's in here. It's wherever you stored that file. So wherever you stored that file, if it's on the desktop, doesn't matter, wherever you put that, that's where you're going to be able to find this code. If you didn't download it from the CD, you downloaded it from the website like I showed you in lesson 1 or lesson 0. Wherever that folder is, you're just going to go into there. So mine happens to be on the desktop, so here it is. Elegoo. Click right here, then choose your language, and then it's going to be under code. So click code, then right here you're going to see lesson 4, RGB LED. Click on that, and it's this one right here. So click that, click upload, boom. You double click that, it's gonna open up. Pull it over here, and it says upload to the program. So at this point, plug in your device. Make sure that it's recognized up here as well as on the port. Once it is, you click upload, which I'm gonna show you guys right now. Boom. We'll click upload in 3, 2, 1. Flicker, flicker, flicker. Boom, and now it's on. And now you can see, hey, that's pretty sick, dude. We got an RGB that's changing colors. Dude, that's sick. That is so cool. Very cool. So let's now look at this code and see exactly how it functions. So, looking at the code. So the sketch starts by specifying which pins are going to be used for each of the colors, right? So define blue is pin 3. Oh wow, that's so cool. Blue is pin 3, green is pin 5, red is pin 6, like we saw on here. Take a look. Here, I'll flip it so you can see it much better. Red is 6, green is 5, blue is 3. And that is exactly what we have in our code. In the setup, pin mode red, output pin mode green, output pin mode blue, output digital right, red, high. If you remember, high means on, low means off. That's what we learned in the last LED setup that we did. Okay, so the next setup is to write the setup function. So that's what we just talked about. Before we take at the loop function, let's take a look at the last function in the sketch. The define variables, so red, which is 255, chooses a value between 1 and 255 to change the color, like we talked about. So that's interesting. So let's take a look. In the loop, what I'm going to do is I'm going to comment all of this out because I'm interested to see. Go. There we go. So I commented everything out in the loop because if you guys noticed, when we first uploaded this code, watch, I'm going to do it right now. I saw the LED flicker red. So let's see. Boom. Uploading. Flickers red. Stays red. Why is it staying red and now it's not changing? Well, the reason why it's staying red and not changing is because in the setup, the digital write function only turns the red LED on with the high voltage. So if we change this to high, the green one, what color are we going to get? Well, red and green, if we come back up to our little picture, red and green, we should get a yellow. So let's try to upload this again. Boom. I'm going to upload it right now. Boom. Look at that. Yellow. Wow, that's cool. Awesome. And then we'll go ahead and uncomment everything in the loop function. One thing I will say is I do not like how this code is formatted. It's kind of bugging me. So what I'm going to do is I'm going to go ahead and format this correctly. Alright, there we go. So I just formatted the code. I personally like to have my code formatted in a correct way. I don't know, maybe it's just because we're bringing the code into Arduino and it doesn't know how to recognize it. I don't know. I like to format it so it looks nice. So anyway, reading on. So the next step, this function takes 3 arguments, one for the brightness of the red, green, and blue LEDs. In each case, the number will be between 0 and 225. 0 is off, 255 is the maximum brightness. The function calls analog write to set the brightness of each LED. Analog write right here. Boom. Red value. Red value. Minus equals 1. Boom. Pretty cool. Try adding a few colors of your own to the sketch and watch the effect. Very cool. Now, explaining this code a little bit. A for loop, if you guys don't know, simply does whatever's in this block of code this many times. And this right here is how many times we will increment through this list, through this block, starting from this point. So basically you start with whatever this value is right here. So we're starting with 0. We're going to say we want to go up to, but not including 255. And we want to increase, each time we go through, we want to increase this value, I, by 1. Pretty simple, right? So red value minus equals 1, green value plus equals 1. Essentially what that's doing is it's starting with these values right here. So we're starting with red being the only color that's on, green being off, blue being off. So that's why when we started this function, boom, if we come back, we run it, we'll see that it starts with red. See, it starts with red, then it turns to like a green, then it turns to cyan, then blue, then purple, orange, yellow, red, orange, yellow, and then it loops. Cool. So the way that it's doing this, let's see. So it starts with red, and then what's it going to do? It's going to decrease the red and increase the green. So if you decrease red and increase green, you start to get yellow. So you're going from red to orange to yellow to greenish yellow to green, right? And if we look back at this, that's exactly what it's doing. Watch. So red, orange, yellow, green, and then it's literally just cycling through, and you guys can see it, through this color band right here. It's literally just doing this. And the way it's doing that is by changing the values in the code, which is pretty cool. So the analog write, so for this loop right here, it's going to go through and exhaust all of this red. It's basically taking what's in the red, right? Because it's starting at the red is 225 and the green is 0. Every time it goes through this loop, which it's going to go through 255 times, it's decreasing the red and increasing the green, right? Until it's just green. After you get done with this loop, boom, it jumps to this section of the code where it sets red to 0, which it's already at after you get through this function. Green, which is at 225, which it's already at after this function. And then the blue value, which is still 0. We haven't touched the blue yet. So now it's just like we're doing it from up here, going through this block. Now we're going to start here. So we're starting with green. And what are we doing? We're subtracting. See, same exact line of code here for up here. Because we're going through 255 values of the RGB. Because it's 256, starting with 0, ending with 255. So at this point, only green is lit up when it enters into this block of code. So at that point, green is at 255, blue is at 0. And what happens? So every time it goes through the block of code, it's subtracting 1 from green and adding 1 to blue. Until, boom, you get to the end. And as you can see, just the blue is there. Now the green is 0 and the red is 0. And then it just restarts. Then we have blue at 255, red at 0, and until red is back at 255. We reach the end of our loop function. We come back up here, and bingo bango. Dunzo Dorinzo. We just restart the whole process. Which is why our RGB just keeps looping, just keeps doing the exact same thing. It just keeps changing colors until the end of time. Or until I turn it off. But pretty cool, right? Pretty cool lesson. You guys now know all about the RGB LED and how the code actually works. But I thought this was a really cool lesson. If you guys liked what you saw, make sure you guys smash the like button. Drop a comment down below. Subscribe to the channel. I'm going to be finishing every single lesson in here. Our next lesson, we are going to do digital inputs. I can't wait. Basically, we're going to have this button, which you press, which is going to turn on the LED or turn it off. I can't wait for this next lesson. So thank you guys for watching. I really appreciate all the support. You guys have a beautiful day, beautiful night, wherever you guys are. Dylan is out.